Good day, everyone. Today's lesson is going to be a very basic or a simple example of how to use Rayleigh's method in order to determine the fundamental natural frequency of a torsional system. So basically here we're dealing with a torsional system. And this, in another example in later videos, I will be doing a translational system, or basically rotational and translational, basically a translational system. Okay, to start with, first of all, Rayleigh's method. Consists of this very simple formula here. Okay. Rx equal to omega squared equal to, that's your mode shape, x transpose your stiffness matrix, x x transpose, that's your also your, and here your mass matrix, and x. So basically, let's change colors here. So basically, three important things that you need to know. Usually in these type of problems, we don't have the mode shape is to be assumed. So mode shape, you assume the mode shape. X. And the second key here is to find the stiffness matrix. And the third thing is basically to find the mass matrix. Find the mass matrix, or inertia matrix, basically moment of inertia matrix. Okay, so let's move on. So the example here, it says, they're asking us to find the fundamental natural frequency of the torsional system using Rayleigh's method. So the system is basically a compressor. So it's got the shaft here, and it's got a compressor here basically. And then maybe I should draw the compressor a little nicer. So this is basically, if you guys don't know, this is a symbol for a compressor in thermodynamics. And then we have three compressors basically working together, and they're all attached to one shaft. And each one has a moment, MT1, MT2, MT3. So we've got a compressor here, and we've got a turbine, and we've got a generator basically. Oops, I drew the wrong symbol for the generator, but whatever. And their direction of rotation is basically this way here. So theta 1, theta 2, theta 3. And then we've got KT1, KT2, KT3. Alright, so first things first, always to find your stiffness matrix, you have to draw the Freebody diagram. So first step is Freebody diagram. Second step is so usually for a translational system we use sum of forces, but here we're going to do sum of moments because it's a translational system. and then number 3, theta 1 equals 1, theta 2 equals theta 3 equals 0, and rotate. And I'll tell you what I mean by this here in a second. Okay, so let's move on. Let's draw the essentially now let's draw the free body diagram. We're going to go to a new page here. Alright, so let's pick a new color. Let's go with blue. Okay, so that's your so J1 here, J2, J3. Oops. Okay, so for this here, KT1 is equal to theta 1 times theta 1, K2 2 is equal to theta 2 minus theta 1, KT3 is theta 3 minus theta 2. Obviously, MT1 here, MT2, MT3. All right. Okay. So we've got the free body diagram right now. So now let's move on to getting the equations. Let's go to a new page here. Okay, we're going to pick a different color. Actually, let's go with color here. Okay, so for mass, for this mass here for body number 1, so J1, we've got force here, and then got the force there, so KT1 theta 1, KT2 theta 2. So in here on this you have to assume there is another MT1. So this is different. This is basically, this is different than this MT1 here. It's totally different. It's not the same thing. This is what we do. These are the steps in order to determine. So step 1, determine stiffness matrix. And these are the steps in order to determine the stiffness matrix. So let's do sum of moments equal to 0, and you always assume the direction of motion to be the positive. Okay, so let's move on. Let's speed up here. So MT1, that's positive, minus KT1 theta 1 plus K2 T2 theta 2 negative theta 1. So there you guys have it. So that's your first, equal to 0. That's your first equation. Oh, man. Okay. And now your second equation, your second body, so J2, you've got 2 moments there, and MT2. I'm going to do that as well. So MT2 negative. So that's K. So that's the same thing, right? And then for this here, So that's going to be KT3, sorry. KT3 minus theta 2. Then, okay, so positive MT2, positive, and then negative KT2, theta 2 minus theta 1, plus KT3, theta 3 minus theta 2 equal to 0. That's your second. Now to the last one and third one, we have MT3, we've got MT2 here. Sorry, KT3 times 3 minus theta 2, so let's do that. Negative KT3, theta 3 minus theta 2 equals 0. That's your third equation. So that's really good. That's your first step. You've derived the equations, you summed the moments here for each body diagram, for each for body. Now we're going to take all these equations and basically move on and do the next step here. Okay, so let's divide this here into 3 columns, and I'm going to say theta 1 equals 1, and then theta 2 equals theta 3 equals 0. Let's say theta 1 equals theta 3 equals 0, and then theta 2 is equal to 1. That's what I meant by rotating. So basically, it's like circulating the 1 there. So theta 1 equals to theta 2 equals to 0, theta 3 equals 1. So let's plug in these thetas back into the equations and find what each MT is equal to. And actually, before I do that, I want to explain something here for the stiffness matrix. So the stiffness matrix is basically, it's going to look like this. So MT, 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 check, MT, MT. So we've got row number 1. Actually, let's do another color here. Row 1, row 2, row 3, column 1, column 2, column 3. Okay, so now it's really important to understand that this stiffness matrix here, that's basically, so this column here, that's going to be for theta 1 equals 1, theta 2 equals theta 3 equals 0. And this here is going to be for theta 1 equals theta 3 equals 0, theta 2 equals 1. And the last one here, last column, theta 1 equals theta 2 equals 0, theta 3 equals 1. So that's basically, sorry, just let me drink some water here. So basically that's how it works. And remember, you can also do that for, a row basically. One thing that is really important to understand here, that you should know that this value here is going to be equal to this value here, and this value here is going to be equal to this value here. If you don't get the same value for both, then you know that you've done something wrong. And then this value here is going to be equal to this value here. This baby here, this diagonal, is going to be unique. So it would be a coincidence. It would be. It's not. You don't. I mean, it's not necessarily. You don't. It doesn't mean. It doesn't necessarily mean that you won't get these to be equal to each other, or MT1 is equal to MT3. That is possible. I'm not saying not. I'm not saying no, but usually they're unique. They shouldn't be equal to each other. They're not necessarily equal to each other. I should put it that way. Okay. So we got that down now. So let's go back to figuring out the okay, let's go. Okay, so MT1. So that's going to be negative KT1, and then that's going to be plus KT1, KT2 times negative 1 equals 0. So MT1 is basically KT1 plus KT2. Second equation of motion, so MT2. This actually should be MT1. This should be MT2T. Yeah, pretty much. KT2 negative. So negative negative, that's gonna cancel out. It's gonna be negative KT2 equal to, that's gonna be 0 0. So MT21 equal to negative KT2. MT3. So MT3 here is basically going to be equal to 0 because theta 3 and is equal to theta 2, which is equal to 0. Let's do the next one here. Actually, let me change colors real quick here. I'm just going to put that 8. Okay. So actually, you know what? Let's fill out a matrix as we go along. So make it big and nice. So KT1 plus KT2, that's going to be our first entry in the matrix. This is going to be negative KT2. That's going to be a 0 there. So we've got 2 more columns to go. Let's try to speed this up here. So if you notice here, MT, oh man, okay, that's going to be basically negative KT2, and MT22 is equal to KT2 plus KT3. MT is going to be, sorry, that's MT3, that's going to be negative KT3. It's just basic arithmetic, basically. Nothing special here. And now for the last one, MT1 is MT, that's, we're going to call that, actually we're going to call that, just refer to them basically by the entries. That's what I'm trying to do here. It's 1, 3, right? Yeah, that's pretty much right. That's going to be equal to 0. MT2, that's row 2, column 3, that's going to be equal to negative KT3. And that makes sense because this should be equal to this value here, right? So that makes sense. And then MT3 is equal to KT3. Okay, so let's go and fill these up real quick. It's going to be negative KT2. This is KT2 plus KT3. Negative KT3, that's a 0. Negative KT3, that's KT3. Okay, excellent, good. We have found the matrix. Okay, so I'm gonna cut this video here. I'm gonna cut this short because it's I think that's going to be too long of a video. In part 2, I'll continue the example of how to actually use a formula. And thanks. Looking forward to seeing part 2.